is week 2. That started late. This is week 2. Pardon my appearance. I have just gotten out of the shower and I do look a little psychotic. Textbook and class notes and my cat, Hello Maui, featuring Maui. Please keep walking. No, he wants to attack me. Cool. So, where do I begin? You want us to draw a promoter with no damage. And you want us to do it for P21. That. P21 is, the function of it is to slow down the cell cycle till damage is fixed. That will come in handy later. So, I'm going to draw a line. We're going to draw this. We're going to do this sideways. Wow. So I'm going to put the ta-ta box right here. And as you can see, or I hope you can see, the ta-ta box is from negative 25 or negative 35 to negative 25. I'm not going to write that on here, but just keep in mind 35 and 25. So that's just a lot more work that I don't want to do. And then P53. This is where P53 is going to be, and that's at negative 2,283. Again, not going to write that. So, it is asking what would happen to a promoter with no damage, and what that would look like is it would just have an X through it, because like I said, P21 thrives when there is damage. It slows the cell cycle down till the damage is fixed, and so nothing would happen. So I'm going to leave that one right here, because in number 2, it asks what would happen if there was damage. So we're going to do the same exact thing, just a little neater. And then we're going to do the ta-ta box. Again with the base pairs, 35, 25, and then P53. If I can write it. Oof. Okay. So, a promoter that would have damage would look something like this. It would have an RNA polymerase 2 attached with all of the transcription factors. And then there would be a homodimer, if I can draw it. A homodimer binded at P53, and this would allow for transcription to occur. And also there can be an RNA polymerase here as well, but as long as that doesn't bind, then there will be no transcription. So what is the difference between the both? Well, they both can have RNA polymerase, but the homodimers does not bind to the P53, and with the no damage, there's no transcription, and for this one, the second one, with the damage, there would be transcription because the homodimers, again, can bind. And then what would happen to cell cycle in 1? So nothing would happen to the cell cycle in P21. Well, actually, things would be happening. But what we're looking for is that the cell cycle is slowed down, and that would occur when there is damage. Because, again, this thrives in an environment where there is damage. And if there is no damage, then the cell cycle is just going to keep doing its thing. But when there is damage, it is going to slow down because of P21.